Alrighty guys, welcome back. Today we're going to be finishing up the 5x114 hub swap for the front of this Prius. We already got the rear done. I did a video on that already. The front requires a lot more work. So over here we have the 5x114 hubs from a Scion IM. It also matches a few of the other cars too. But the problem with Toyota's 5x114 hubs is that none of these dimensions are the same as the OEM 5x100 hub. So I sent these to my friend to get machined. So special thank you to Brett. He was the one that machined these for me. So this bore was made larger to accommodate the larger race on the bearing. And then we had new bolt holes drilled for the bigger bolts. The OEM hub uses M10 bolts, but we're sizing up to M12 bolts, so I actually used the same exact bolts that hold the caliper in place. So I got 8 new ones right there to hold the bearing inside the knuckle. We have the rotors from a Toyota Previa. I'll put all these part numbers up on the screen. Now this is the closest rotor that we could find that would match all the same dimensions, but also have the larger bore for the hub as well as the 5x114 bolt pattern. Now the only difference is these are about 3 millimeters taller than the OEM rotor, so that means the rotor would sit inwards about 3 millimeters. So to alleviate that, I had a friend of a friend, shout out to Leroy, thank you, machine this spacer. So this is just a 3 millimeter 5x114 spacer or shim, whatever you want to call it. This is going to go behind the rotor, and this should space the rotor out and put it in the exact same position that the OEM rotor would be in. And other than that, I believe that's all I had to do. So machine the knuckles, new rotors, new hubs, and new bolts. And then we're gonna go ahead and put all this together. And then after we do all that, hopefully this will be now 5x114 in the front. I forgot to mention, the axle nuts are only supposed to be one-time use. So I bought 2 new axle nuts for either side, and then I ended up bending and messing up one of the castle nuts when I took this all apart. So got a brand new castle nut right there. But the cotter pins you actually do not need to bend. They're a pretty cool design. It's like a spring design basically, but the cotter pins can be reused because you don't actually have to bend them. So that's pretty cool. But yeah, I think that's it for all the new parts that I had to get. So I don't know what the easiest order to do all this is going to be, but what I'm going to try for this side is put the bearing inside the knuckle, put the 4 bolts in, get it onto the ball joint, get all that torque down, then kind of maneuver the axle into the new bearing, and hopefully we'll have enough wiggle room to do all that. That is how I took it apart. So we're going to try that. The torque spec for the OEM bolts, even though they're smaller than this, is 30 foot-pounds. Since I don't know the torque spec for the larger bolts, and this is kind of an unorthodox procedure, we're just going to torque the bigger bolts to 30 foot-pounds as well. But we're going to put a little bit of blue Loctite on the edges where the threads engage so that there's no vibration or anything that could potentially work these bolts loose over time. Alright, so we got these 4 bolts torqued down to 30 foot-pounds with our blue Loctite. Now we're going to go ahead and put it on this ball joint stud, and then we're going to torque the castle nut to 36 foot-pounds and place the cotter pin for the castle nut. Alright, here's the castle nut. We had to make it a little bit tighter than we anticipated to get the hole to line up with the openings on the nut. But this is the cotter pin, so basically one end goes through the hole, and then the other end you just pull out, and then it engages and locks into the slots cut into this castle nut. Here's what the cotter pin looks like once it's engaged. So in order to torque that, I actually had to temporarily put that tie rod end in place in order to prevent the knuckle from spinning as I was tightening it. But now probably what I'll do is take this tie rod end back out so that I can wiggle the knuckle outwards and then get the axle into the wheel hub there. We now have our axle in place and started. So we're going to start tightening our axle nut. This is a 30 millimeter 12-point socket. Let's see if I can get this started. Okay, got this started. So this is the 30 millimeter 12-point socket. Now this is going to be kind of hard to get on because it's designed to lock as it's threaded on. So get it as much as you can with the ratchet, and then when the time comes, we'll be torquing this to a final spec of 159 foot-pounds. So as you're putting all this stuff back together, it's not a bad idea to put anti-seize on a lot of the components. One of them is the axle splines. So we couldn't get the axle in all the way, and this is as far as we can get the nut for now. When it comes time to actually get this nut on all the way and torque it, you would need the wheel on and the car on the ground to prevent this hub from spinning as you torque the nut. So once we get the rest of the suspension and the coilovers and stuff, and we get this on the ground, we're going to torque this nut for sure. But for now, that's as far as we can get this. So next we're going to put the tie rod in, which is just like the ball joint. So it's going to go through, we're going to put the castle nut on, 36 foot-pounds, put the cotter pin in, and then we should be ready to put the rotor and all that good stuff once that's all done. The tie rod end is in, the castle nut is torqued, and the cotter pin is in. So now what we're going to do is put this 3mm shim on here to give the brake rotor the spacing that we need. We're going to put the rotor on, and then we're going to put the caliper on. We're going to be using the same size bolts that we took off originally to attach the caliper here. We now have our shim behind the rotor. You can also put a lug nut on. That's what I like to do to keep the rotor in place as you go to put the caliper on. So the two 17mm bolts on the back that hold this caliper to the knuckle, we're going to torque those to 101 foot-pounds. So we got the brake caliper torqued down now. So we're just going to reconnect this bracket for the brake line right here. And then we're going to torque that, I believe it's a 12mm bolt, down to 14 foot-pounds. And then we would do the other one, but we don't have the coilover for it to mount to yet. So we're going to do that. And then we're going to kind of route this ABS line. I actually rerouted it through the inside of the car so that the wheel doesn't rub it. And then we're going to route this alongside the brake line. And then it's going to go back into the ABS port, which is down there. And then I think the torque spec for this is like 75 inch-pounds. It's a super small bolt, so just don't be stupid and over torque it because the knuckle is only aluminum. Whew, and that is it, guys. So we torqued everything that we can, not having the strut there, and then not being able to torque this until the wheel is on and it's on the ground. But we got the caliper and rotor, everything on. Everything's torqued, cotter pins are in place. Hopefully I have enough slack in this ABS line. I gotta verify and do a full lock left later when I have the coilover on to see if this will be long enough. But it looks like it will be. But yeah, now we're officially 5x114 in the front, so good stuff.